Continuing on with the extra buoyant problem, we're going to go to problem 3, which asks for the volume of ethanol that is displaced during the process here. So in order to get through this one, what we're going to need to think about is the fact that we have put this block into the block of chromium metal into an ethanol, and we're going to need to figure out a way to find the volume that's displaced from this. One thing that might come to mind when we're thinking about volume is that same equation that we used before. So volume equals mass over density. So we'll see the same seems to apply here. We do have the density of ethanol given in the problem, but when we think about the mass, we don't really have anything else that's given to us about this ethanol, and it doesn't really seem like we're going to be able to get that based on what we know right now. So because the mass isn't something that we can find at the moment, it looks like we're going to have to reroute a little bit. Because of that, we should get a different equation or some other relationship that we can use. The key for this is going to come from the fact that we're told the block of chromium is submerged in the ethanol. Even if we weren't told that, we could have figured this out from the fact that the density of chromium is much higher than the density of ethanol. What this means is that it should sink in ethanol, so as long as we have enough around, it should go and be fully at the surface. We can then use what we've learned about fluid displacement to find the volume of the ethanol based on what we know about the chromium. The relationship that we'll use is the volume of the submerged object. In this case, that's our block of chromium that we are putting in the ethanol. This volume is going to be equal to the volume of fluid that's displaced when we put it in. To again talk about where this relationship comes from, we can think of the fact that when we put this block into ethanol and the entire thing is under the surface there, the ethanol cannot take up the space that is taken by that block, or that anything that was there previously has to have been moved aside somewhere. And this is what our definition of being displaced is. So because of that, we know that the volume of our aluminum block will be equal to the volume of the ethanol that's displaced. Since we know the volume of the block to be 8,512 milliliters, we can say that that's going to be equal to the volume of displaced ethanol. So that will take us to the process for problem number 3. And we'll set us up ready to go on until to problem 4.